Namaskar. The topic of discussion in this module is on streams and drainages. Physical geography is a major branch of earth science. It involves the study of various geomorphic processes under the branch called as geomorphology. Geomorphology deals with the study of various geological agents that act on the surface of the earth. These agents form various relief features over the globe. Geomorphology is the study of earth's landscapes and landforms, the processes by which these landforms are originated, their age and the nature of the materials which are underlying them. Geomorphic processes are everlasting phenomena acting on the surface of the earth. They are of two kinds, as endogenous processes and exogenous processes. Those processes that are acting on the surface of the earth are called as exogenous processes. Those processes that are acting beneath the surface of the earth are called as endogenous processes. Exogenous processes are those that are acting on the surface of the earth on the rocks and surface materials continuously. The factors responsible for these processes are earth's rotation and revolution, sun's radiant energy, temperature, climate, rainfall, earth's acceleration due to gravity, hydrological cycle, states of transformation of matter and conservation of mass and energy. The geomorphic processes involve erosion, transportation and deposition processes. All these are cyclical in nature. All put together is called as the geomorphic cycle. During erosion, transportation and deposition, the impacts could be noticed in the form of new landforms and modification of existing landforms. Landforms are developed due to these actions. Several factors are influencing for erosion. The notable factors are climate, temperature, moisture, wind blow and radiation, topography, soil profile, geology and structure and drainages. Drainages are controlled by the running water and other aerial agents. River is a major geomorphic agent in this process. River is a powerful geomorphic agent. It has the potential to erode, transport and deposit the materials on various portions of the earth. Fluvial geomorphology is the study of landforms and processes that are associated with rivers. There are twofold action seen in rivers. One is the formation of the valleys and another one is the formation of the drainage systems. A river is evolved from a large number of small network of streams. A stream is a course of surface water flowing on land. Study of streams is a part of physical geography. Hence, in this lesson the following aspects are highlighted: stages of stream development, types of streams, drainage patterns, features of river courses and the drainage basins. Let us see the first part, stages of stream development. If we look at the world's water distribution, about 71% of the earth's surface is covered by water. Most of the earth's water is in the form of oceans, that is 97.2% exist in the oceans. Less than 3% of the water on the earth is located on or beneath the continents, and most of that is in the form of ice, that is roughly about 2.15% is existing in the form of ice. About 0.001% of the earth's water is in the atmosphere and only 0.0001% is contained in the world's river systems. Despite the low proportion of water in the streams, running water is the most important erosional agent on this earth. Running water supplies about 8% of the electricity used in various countries, and it serves as the primary source of drinking water, water for industrial and irrigational purposes, and it is also used for inland waterways as for transportation. The study of streams is a very interesting aspect in geography. Streams are varying in their width from few centimeters to several kilometers and are all occupying large areas in different countries and continents. A river is a large natural body of flowing water. It is a historically significant location for the world's most of the ancient civilizations. Rivers are aquatic ecosystems with freshwater resources. The term is similar to streams, but a river is a larger course of inland waterway than a stream. A stream is a body of flowing water with a current confined within a bed and its stream banks. Streams are important as conduits in the hydrological cycle. Streams support for groundwater recharge. Streams vary in their width from a few centimeters to several kilometers. Streams serve as corridors for fish and wildlife migration. The biological habitat in the immediate vicinity of a stream is called as a riparian zone. The study of streams and the inland waterways is known as surface hydrology. Let us see the parts of a stream. A spring is the point at which a stream emerges from an underground seepage source through joints or fissures or fractures. The term headwaters is used to denote the part of a stream or a river having its close proximity to its source. Every stream will have its own confluence. The term confluence is used to denote the point at which two streams merge together or a river joins with a sea or a lake or a reservoir. A channel is a depression created by constant stream erosion that carries the stream's water. The term stream bed refers to the bottom of a stream. A gauging station is normally located along the route of a stream or a river for measuring the discharge of water of that river. Talweg is a term used to denote a river's longitudinal section or the line joining the deepest point in the channel at each stage from source to mouth. The term wetted perimeter is used to denote the line on which a stream's surface meets the channel walls. Stages of stream development is a unique aspect. Precipitation gives rainfall. Running water over the land produces slope wash. The slope wash of rainwater flowing on the land creates a stream channel. It is called as a stream erosion. Stream valleys form through stream erosion and mass wasting processes. Small rills developed by erosion become deeper and wider downstream by several processes. The major processes are downcutting, lateral erosion and headward erosion. Downcutting is the first process. Water has the ability to dissolve and carry substances when it flows. Downcutting is the primary action of flowing water. It represents downward erosion of the stream channel. It occurs when the stream energy exceeds the stream's load and causes valleys to be narrow and steep sided. This action creates canyons and gorges along the river courses. Lateral erosion is the second process. Lateral erosion is yet another process done by a flowing water mass. It undermines the part of a river bank or the valley walls. Lateral erosion also leads to mass wasting and widening of the valley. This process is enhanced by sheet erosion and rill erosion. It causes formation of V-shaped valleys which are common along the stream courses. Headward erosion is the final stage. It involves lengthening of the valley upstream by erosion of headwater up to divide areas. Sometimes it can also result in the creation of stream piracy. It diverts a part of a stream's drainage into another stream. It happens because of the headward erosion of another stream located adjacent to one stream. River valleys are developed in stages. There are three mechanisms involved in the river valley development like deepening, lengthening and widening. A river and its valley go through these three major stages as youthful stage, mature stage and old stage. The longitudinal profile of a river is also yet another important aspect. The longitudinal profile of a stream is a plot of elevation versus distance of a stream along its flow path. It usually shows a steep gradient near the source of the stream and a gentle gradient as the stream approaches its mouth. There is yet another parameter called base level of a stream. The base level of a stream is defined as the bottommost level below which a stream cannot erode its channel. For streams that empty into the oceans, the base level is always the sea level. Local base levels can also occur where the stream meets a resistant body of a rock or a dam. A stream's velocity is a major factor to be studied in geomorphology, hydrology and civil engineering. A stream's velocity depends on the location in the stream channel, irregularities in the stream channel caused by resistant rocks and the slope of the stream. The average velocity is the time it takes a given particle of water to traverse a given distance. A stream flow can be either laminar or turbulent. In laminar flow, all water molecules travel along similar parallel paths. In turbulent flow, the individual particles take irregular paths. Turbulent flow can keep the sediments in suspension longer than the laminar flow. It also aids in the erosion of a stream bottom. Average linear velocity is greater in laminar flow than in turbulent flow. The sediment load is an important aspect. The sediment load in a stream is a major part. The rock particles and dissolved ions carried by the stream are called as the stream's sediment load. A stream's sediment load is divided into three parts as suspended load, bed load and dissolved load. The suspended load is one in which the particles are carried away along with the water in the main part of the streams. The size of these particles depend on their density and also the velocity of the stream flow. Higher velocity currents in a stream can carry larger and denser particles. The bed load of a stream contains both coarser and denser particles that remain on the bed of the stream most of the time. These move by a process called saltation or jumping. It is also possible that the sediments can move between bed load and suspended load as the velocity of the stream changes. The dissolved load of a stream denotes the ions that have been introduced into the water by chemical weathering of rocks. This load is invisible because the ions are dissolved in the water. The dissolved load consists mainly of bicarbonate ions, calcium ions, sulfates, chloride, sodium, magnesium and potassium ions. These ions are carried finally towards the oceans. They ultimately increase the salinity of the oceans. A lot of changes happen along the downstream course of a river. Along a stream in the downstream direction, several changes happen. The river water discharge increases. When water is aided to the main stream from many tributaries and groundwater, the river discharge increases. As the river discharge increases, the width, depth and average velocity of the stream increase simultaneously. The gradient or slope of the stream will also decrease because of the erosional activities.